Hi guys, today we're looking at more heat calculation questions. So we're going to look at exercise 15.2, question 14. A hailstone has a mass of 3.5 grams and is at a height of 3 kilometers. What is the potential energy at this height? And then part 2, if all of this potential energy is converted to latent heat during the fall, calculate the mass of the hailstone on reaching the ground. Okay, so part 1, we want to find the potential energy of your hailstone. So to find our potential energy, we go to our log tables and we find an equation for potential energy. On page 55 of our log tables, we're told that our potential energy is equal to mgh. That's mass times gravity times height. We're told that the mass of your hailstone is equal to 3.5 grams. And we're told that the height is equal to 3 kilometers. The first thing we must do is convert our values from grams to kilograms and kilometers to meters. To convert it from grams to kilograms, we divide our value by 1,000. This gives us our mass of 0.0035 kilograms. To convert our height from kilometers into meters, we multiply by 1,000. This gives us 3,000 meters. So we have m and we have h. We also need g, our acceleration due to gravity. This is 9.8 meters per second squared. From this, I can find my potential energy, which is equal to 0.0035 times 9.8 times 3,000. Let's just move that over a bit. So times our 3,000. This gives us, in our calculator, 0.0035 times 9.8 times 3,000, a potential energy. So our hailstone has a potential energy of 102.9 joules. Let's look at part 2. We're told that all of the potential energy is converted to latent heat during this fall. And we're asked to find the mass of our hailstone. So all of our hailstone is going to be converted from a solid to a liquid as it falls to the ground. It gains its energy from the potential energy, and we need to find the mass. As with all heat calculations, start off by drawing a diagram and stating the energy lost by one system is equal to the energy gained by another. So I have my hailstone up at a height, and this is going to fall down and be converted into a liquid. It gains its energy to convert from a solid to a liquid by gaining the potential energy that is lost as the object falls. So where is our object losing energy? It's losing potential energy. And how is our object gaining energy? Our hailstone, is gaining energy by changing state from a solid to a liquid. From here, we substitute in what we know. We know that it loses 102.9 joules of energy we want to find the mass of our hailstone. If our object is changing state, the energy gained is gained by Lm, where L is the latent heat of fusion, because our object is changing from a solid to a liquid. Substituting in what we know, our latent heat of fusion of ice is equal to, just up here in the corner, 3.3 by 10 to the power of 5. We don't know what the mass of our hailstone that's converted into a liquid is. That's what we're trying to find. So to find our mass now, we divide our equation by 3.3 by 10 to the power of 5 to find the mass of your hailstone, which gives us 102.9 divided by 3.3 by 10 to the power of 5, which gives us a very small mass of 3.12 by 10 to the negative 4 kilograms, or 0.000312 kilograms. So in this question, as our hailstone falls to the ground, the hailstone gains potential energy and uses that potential energy to change from a solid into a liquid. So the energy lost as the object falls, the potential energy lost as the object falls, is given to the energy used for our hailstone to change state. Okay, so if your object is falling, the energy lost due to potential energy is equal to the energy gained by the object, in this case, to change state.